All right, so now we're good at naming ionic compounds. We're also good at identifying what ions are in those ionic compounds. We're also good at counting the number of ions in those ionic compounds. All right, we've learned that ionic compounds that contain transition metals have to have a little extra something when we're naming them, right? Like iron 2 sulfate or iron 3 sulfate. That 2 or that 3 tells us something about that compound. If I say I have iron 2 sulfate, what is that 2 telling me, Tom?
There's 2 irons.
Is it telling me there's 2 irons?
Wait, no, it's showing me that it's a positive 2.
That's right. It's showing that the iron is a positive 2. And if I looked on the list and saw that the sulfate was a minus 2, then those would come together in a 1-to-1 ratio, right? So that 2 there, again, people get confused frequently thinking that that means that there's 2 of these or 2 of these. But it doesn't mean that. It means that the charge on the metal is whatever that metal or that number is. Okay? Very good. So, now I'm going to teach you how to name molecular compounds. Now, molecular compounds have only nonmetals in them, right? And so, for example, this compound, CO2, do you remember the name of this compound?
It is cobalt.
All right. No, sorry. Carbon.
Oh, wait.
And that's a big O, so that's oxygen. You might not know it. We worked with it a while back, talked a little bit about it, but it's called carbon dioxide. Carbon dioxide.
Carbon dioxide.
Very good. And the di is telling me that I have 2 of these oxygens. 2 of the oxygens. All right. So, if I had this compound where it's just 1 oxygen, then I would call it carbon monoxide. All right, carbon monoxide, because mono refers to 1, and there's only 1 oxygen. You see, when I combine sodium with chlorine to form sodium chloride, right, there's only 1 compound that can result. I'm never going to have something like that. I'm never going to have Na2Cl or something like that, or NaCl2, right? Those can't exist because sodium always forms a +1 charge and chlorine always forms a -1 charge. Therefore, they can only come together in a 1-to-1 ratio like that. So if I say sodium chloride, nobody has to know if it's monochloride or dichloride because there's only one way that those elements can come together. Okay? So, we don't use mono, di, and tri, and these different prefixes, we call them, when we're describing ionic compounds. However, for molecular compounds, there is often multiple ways that 2 different kinds of elements can come together. So, for example, carbon and oxygen can come together as carbon dioxide with 2 oxygens, or carbon monoxide with just 1 oxygen for every carbon. All right? So in molecular compounds, when we're naming molecular compounds, we use these prefixes. Mono, di, tri. Have you heard of a tricycle, right? That you knew that tri means 3, right? Now tetra. Tetra is kind of one that people aren't familiar with much. But there's a game out there called Tetris. I don't know if you've heard of Tetris, but there's little segments of blocks that have 4 units of 4. And also you try to line everything up so that there's 4 lines that will disappear at once, and they call that a Tetris. The term tetra refers to 4. All right? Penta, a lot of people have heard of a pentagon. That's a 5-sided figure, right? So there's our pentagon. Hexa, that's a 6-sided figure, hexagon. Hepta is not one that people are very familiar with, but octa, what am I drawing here?
Octopus with 8.
Yeah, octopus. All right. All right, and 9, nona. Not a lot of people are familiar with that one either, but deca, as in a decade, that's 10 years. What were you going to say?
Decade.
Yeah, decade, 10 years. Decimal, the word decimal means every 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 10, you switch over 1 point in the decimal, right? In your decimal place. So the decimal system works off of 1 through 10. Okay? So we have to have a way to remember hepta and nona. And this is the way that I remember it. Okay? So mono, di, and tri are easy. Penta and hexa, if you've heard of a pentagon and a hexagon, those are pretty easy. Octa, 8, octopus, that's pretty easy. And deca, decimal, decade, that's pretty easy. But how are we going to remember hepta and nona? Tetra, we already talked about how we can remember that, Tetris. But how are we going to remember hepta and nona? And this is something that helps me. A long time ago, the calendar used to be only 10-month calendar, a 10-month calendar. So that it would go January, February, March, and get to the end, and then it would December, and then it would start over again. But December, and that's where we get the dec for December, was the 10th month. Known for November was the 9th month. It's Nov. October was the 8th month. September was the 7th month. Sept, right? What happened was they decided they needed 12 months, and so they added 2 months into the calendar, and they named those months after Julius and Augustus Caesar. So that's July and August. July and August. So Julius and Augustus Caesar got their own months, and then it moved all the months back by 2. So September became the 9th month, October became the 10th month, November became the 11th, and December became the 12th. It's a shame they didn't change those. Dodeca, that could have been Dodecember. Dodecember, that means, the 12th month. December really means the 10th month. But that's where we got them, and that's what we can use to remember hepta. Sounds like septa, 7th, and it used to be the 7th month. And nova used to be the 9th month. Sounds like nona, November. Okay? So, if I have regular compounds like hydrogen chloride, that's hydrogen and chloride coming together. That's just one hydrogen and one chlorine. All right? If I have a phosphorus and pentachloride, then what is this telling me? What are my 2 elements in this compound?
PO.
P. Phosphorus. This isn't phosphate. This is just phosphorus. So it's P. And what's the other element? What is that pentachloride trying to tell me? What does penta stand for? Do you remember?
10. Oh, no, 5.
Huh?
5.
5. So when it's saying pentachloride, 5 what? What is it saying?
5 phosphorate.
No. Phosphorus, there's just one phosphorus, but then the pentachloride, meaning 5 of the chlorines. So PCl5. All right? Let's try this one. Triselenium dinitride. Triselenium dinitride. So what's the chemical formula for this molecular compound? Can you find selenium on the periodic table? It's number 34.
Oh, Se.
Se, good.
There's 3 of them.
Yeah, so Se3.
And 2.
It's the nitrogen, right? Just nitrogen.
2 nitrogens.
Yeah. Se3N2. Now, just like in the sodium chloride, the last word, last element, always goes to ide. Chloride, nitride. Okay? All right. So mono, we don't use mono usually on the first element. So if the element, if there's just one of them, you don't have to say monohydrogen, monochloride. And we don't say mono on the second one very often either. Okay? But sometimes you do, and you'll get used to it. Like carbon dioxide and carbon monoxide, we always say carbon monoxide because we have to distinguish it from carbon dioxide. Okay, so we're going to skip that one. Let's do these ones right here. Here are some molecular compounds. What is the name of that first compound?
Is that chlorine and what is this? Sulfur?
Yeah. So the sulfur comes first, and the chlorine comes second.
Chlorine.
Sulfur what?
Sulfur, chlorine, and the chlorine has 2.
All right. So how do we name it when it's a molecular compound? We say sulfur. If we want to show that there's 2 chlorines. What was the Very good.
Chlorine.
And we don't say chlorine, but we change it to what?
Chloride.
Very good. Sulfur dichloride. Very good. All right. HF.
Oh. Hydrogen. Fluorine. Hydrogen. Fluoride.
Fluoride. Very good. Hydrogen fluoride. Fluoride. Very good. Hydrogen fluoride. Okay, here's a hard one.
Dinitrogen.
Very good. Dinitrogen. What was the word for 5? Penta. Good. Dinitrogen, penta.
Oxygen.
And oxygen ends in what?
Oxide.
Very good. Dinitrogen pentaoxide. Excellent. All right, so which one of these is the correct formula for nitrogen triiodide? Nitrogen triiodide.
None of the above.
None of the above? What should nitrogen triiodide look like?
NO3.
Nitrogen trioxide?
Yeah.
No, this isn't nitrogen trioxide. This is nitrogen triiodide. What is iodide? Look at element 80 or 53.
53. That's iodine.
That's right. That's iodine. But it changes to what?
It changes to triodide.
It changes to iodide. So what is
The answer is B.
That's right. Very good. The answer is B. Nitrogen triiodide is Ni3. Way to go. How about this one? What's the correct name for P4O10?
Or O10. P4O.
P4O10. What's the name of that compound?
Oh, it's on here. It is phosphorus 4. And dioxide.
Say it nice and clear on the microphone.
Tetraphosphorus, and decoxide.
Oh, very good. Very good. It's B, right? Tetraphosphorus decoxide. Very good. Excellent work. All right, this is a little chart. We don't really need to use it. It's in the book, though, if you ever want to go and look at it. It helps you kind of follow a guideline of how to name a compound. But the 3 ways that we name compounds are, if it's an ionic compound, then we say the first element and the last element. If it's an ionic compound that contains the polyatomic ion, right? We have to say the name of the polyatomic ion instead of the element. If it's an ionic compound that contains a metal from the transition metal, then we have to add a Roman numeral in there to tell people what's the charge on the metal. If it's a molecular compound, then we name it using the di, tri, monodi, tri, tetra, all those different prefixes. Okay, very good. I'm going to tell you a little bit about some other naming. This is naming of carbon-containing compounds. Now, you don't need to remember this. We'll mention compounds with these names later on, but when we name compounds that contain carbon, it's naming organic compounds, right? These organic compounds. We have different prefixes for 1, 2, 3, 4, and so forth. Specifically for 1, 2, 3, and 4, 1 is meth, 2 is eth, 3 is prop, and 4 is bute. 5, 6, 7, 8, 9, and 10 are all the same. Penta, hexa, hepta, octa, nova, or nona, and deca. All right? But for organic chemistry, 1, 2, 3, and 4 are slightly different. Instead of using mono, di, tri, and tetra, they use meth, eth, prop, and bute. Okay? And sometimes we'll refer to compounds like methane, ethane, propane, butane. And you see how methane is just 1 carbon and 4 hydrogens. Ethane is 2 carbons, and each of those carbons has 3 hydrogens on it. All right, so these are, again, organic compounds, and they just contain carbon or hydrogen. All right, here comes a little quiz for us. Should we try to name all these different compounds? Now, this is a mix of, or these ones here are all ionic compounds. So we have to remember our method for naming ionic compounds. Okay, is this disodium oxide? Is that a good name for that compound?
No.
No. Why can't I call it disodium oxide? When do I use di, monodi, tri, those numbers, or those prefixes?
That's only for
Molecular?
molecular.
That's right. It's only for molecular. And what kind of compound is this sodium and this oxygen compound?
It's ionic.
Very good. What's the name of it? What's the name of the compound?
Sodium oxygen.
Sodium oxide. Very good. Sodium oxide. Remember that the last little bit always ends in I. Very good. What's the next one? Potassium.
Potassium and oxide.
Very good. Potassium oxide. Nice. Oh, here's a hard one. What's this one called?
Nitrogen. Hydrogen.
Okay. Hold on just a second. Haven't we seen that NH4 before? What is it when we have NH4 like that?
Oh,
Where have we seen that before?
it's ammonium.
Ammonium. Very good. It's a polyatomic ion, so we have to get out our polyatomic ion chart. Very good. So ammonium, and what's the other polyatomic ion there?
Chloride.
Very good. So the name of the compound is ammonium chlorate. Ammonium chlorate. Very good job. All right, what's the next compound? Hold on just a second, Tom. All right, the next one. What's the name of that compound?
Wait.
Yeah?
CHO is an ion one, right?
Yes, it is an ionic compound. Very good.
But why is there a 2 next to it, a 3 next to it, and a 2 next to it?
Well,
This one
that's
says
one of our polyatomic ions.
Yeah, I know. But it says CH. Oh, it's a different one. There's 2. There's one CHO and C2
C2 H3O2. Yeah.
Yeah, but under it a couple of ways.
Uh-huh.
It's 1, 2.
Yeah.
But looks like it.
Okay.
Okay. So that one's magnesium, right?
Magnesium.
Yeah, magnesium.
Acetate.
Acetate.
Very good. Magnesium acetate. Excellent job. All right. The next one. Cr2O3.
Chromium.
Chromium.
Chromium. Wait. And oxygen. Chromium oxide.
Chromium oxide. Now that's very close, but there's something else missing.
Oh. Chromium. Oh, chromium 3 oxide.
Very good. Chromium 3 oxide. We knew we had to include the 3 because it's a transition metal, right? Transition metal. Very good. How about this last one here?
What's the number to Zn?
What's the number what?
What's the number for Zn?
For BR?
No, Zn.
Oh, it's number 30.
30. Zinc.
Zinc.
Oh, zinc. Where's bromine?
Bromine is 35.
Zinc 2 bromine.
Very good. Zinc 2 bromide. And that's a fine name. That's a very good name. Now, this one, there are a few exceptions, but you don't have to worry about them now. We'll gather them later gradually. But zinc ends up only forming one kind of ion, and so people will also just call it zinc bromide as opposed to just zinc 2 bromide. But very good. Both those names are absolutely acceptable. Okay, now you have to write the chemical formula for these compounds. Calcium hydroxide, copper 2 chloride, and ammonium phosphate. Okay, so let's see you write them down. Okay, calcium hydroxide looks like what? Calcium, very good. Now, did you find the hydroxide ion? What's hydroxide? What element is that? Or is it on the polyatomic ion chart? Is it the third one on the list?
Oh, this side. Hydroxide, yeah.
Okay.
Oh,
All right. Now, is that it? Is that calcium hydroxide?
yeah.
Now, before we decide that, we have to look and see what the charge on each of the ions are, right? What's the charge on the calcium ion? Good. The hydroxide's a -1. What's the calcium? +2, right? Go ahead and put the plus sign in there. Very good. So, what's the resulting compound going to be? 2, one of those, and you need the parentheses around the hydroxide ion, right? And then you don't want to have the charges up there. Very good. Excellent job. All right. How about copper chloride? Copper 2 chloride. What's copper 2 chloride's formula going to be? Copper, good.
Chloride. Oh, chloride.
Chloride, good. Very good. That's a -1. The copper is a what?
Three.
Where is it at on the periodic table?
Oh.
Element number 29?
Yeah.
Okay. So what's the charge going to be? How do we know what the charge is?
Negative.
No.
Oh, positive.
It's in the
Positive.
blue. It's in the blue box. It's going to be positive, but what's the charge on it? +1 or +2? How did you know it was 2? That's right. Copper 2 chloride. Very good. So what's the resulting compound when those come together?
EuEl, and then
Very good. Excellent job. Okay. How about ammonium phosphate?
ammonium. Where's ammonium?
Now, what's ammonium? Is it a polyatomic ion?
Maybe. Oh. It's NH4 positive.
Good. Now what's the phosphate ion?
CO4.
Is that a 3?
Yeah.
Very good. Very good. So what's the resulting compound when those come together? Very good. Now, we need the parentheses around the NH4. Is that right?
Yep.
Very good. Ammonium phosphate. Okay, excellent job. All right, so that's a good place to stop. Well, actually, we only have 3 more slides, and they're just practice problems. You think we can go through these?
No.
Okay, we'll do them next time. Good job. See you next time.